Lesson 4, set operations. Set operations include union, intersection, complement, and difference of sets. In this lesson, we are going to examine these 4 operations with sets. The first operation on the list is union of sets. If A and B are sets, then the union is denoted as this. That is A union B of sets A and B is the set of all elements of A together with all elements of B. In other words, the combination of all the elements in set A and B, avoiding repetition. Alternative expressions of this definition are A union B is equal to set with element S such that S belongs to A or S belongs to B, or S is a member of A union B, which implies S is a member of A or belongs to A, or S is a member of B, where in both statements the word or is used in a sense which includes and. Now, this is the meaning. When you are to combine the elements in set A and B, you also do that with the elements that are common to both sets. So this and denotes the elements common to both sets. That is their intersection, the next operation. That is, A union B is the set of all elements which belong to A or B, including those which belong to both A and B. By this, we have it that the intersection of the two subsets, the next operation, is always a subset of A union B. In set theory notation, under Venn diagram, we denote A union B in this form. You can see that the two subsets are shaded completely, including the intersection of both subsets. That is why the intersection is always a subset of the union. The second operation on the list is intersection of sets. If A and B are sets, then the intersection denoted as this of A and B is the set of all elements which belong to both A and B. That means the elements or elements common to both sets at the same time. That is the intersection. Alternative expressions of this definition are A intersection B is equal to the set with element S such that S is a member of A and S is a member of B. S must be found in both sets before it can be an intersection. That is, A intersection B is a set of all elements such that S belongs to the intersection, which implies S belongs to A and S belongs to B. So that element must be present in both sets. Using Venn diagram, you can see the shaded part, the common element or elements to the two sets, to the two subsets. That is the intersection. The third operation on the list is difference of sets. If A and B are sets, then the difference denoted as this in form of A minus B is the set of those elements of A which do not belong to B. That is clear enough. The elements in set A that are not found in set B. That is the difference between sets A and B. Alternative expressions of this definition are the difference between A and B is equal to the set of element S which belongs to A and S does not belong to B, or S is not a member of B, or S is a member of the difference between A and B, which implies S is a member of A, or S is not a member of B, is not a member of B. All right, the following relation holds. 1. The difference between A and B is equal to empty set if and only if A is not equal to B, or A is a subset of B. 2. The difference between A and B is equal to the difference between B and A if and only if A is equal to B. 3. The difference between A and B is equal to A if and only if A intersection B is equal to empty set. The fourth operation and the last on the list is complement of sets. The complement of any set says P is the set that has every element in the universal set but not present or found in set P. This is the meaning. You have set P and you have the universal set. Now, P complement is the set that has every element in the universal set, but the element or elements are not present or found in set P. In other words, if you remove the element in set P from the universal set, the remaining elements become P complement. That is the meaning. The complement of set P is denoted as P to the power of 1 or to the power of C. The following relationships exist between the difference and complement of sets. Says A, B, C. 1. The difference between A and B is equal to A intersection B complement and it is equal to the difference between B complement and A complement. 2. The complement of A union B is equal to the intersection of A complement and B complement. 3. A complement intersection bracket open A intersection B complement bracket close is equal to bracket open B union C bracket close complement intersection A. Examples number 22. If set R is equal to this and set S is equal to this, find R union S and R intersection S. Solution. The union of both sets is the combination of all the elements, avoiding repetition. This is the meaning. You have 1, 2, you have them there. Now there is 3, there is 3. You record it once, not 3, 3. Then you have 6, 7, 8, 9. That is the combination of the elements in R and S, avoiding repetition. The second one is the intersection of both sets. The common element or elements in both sets. In this case, just element 3 is common. With this, you have answered the question. Example 23. Given that the universal set S is equal to the set with element S such that 1 is less than equal to S less than equal to 20, and A, B, and C are subsets defined as subset A equal to multiples of 5, subset B equal to multiples of 4, subset C equal to multiples of 3. List the elements of A, B, C, A intersection B, A intersection C, B union C, and show that this expression is equal to this expression. Solution. First, you have to list the elements in the universal set. By this given range, you list the elements between 1 and 20 inclusive. You have the universal set. Subset A is the set with elements multiples of 5. From here, you list all the elements that 5 can divide. You have this subset. Subset B is the set with elements multiples of 4. You list all the elements in the universal set that 4 can divide. You have this result. Then subset C is a set with all the elements that 3 can divide. In the universal set, you have this result. So we have listed the elements in A, B, and C. We continue and list the other elements. We continue from here. A intersection B, that is the element or elements common to set A and B, and you have 20. The next, A intersection C, the element or elements common to set A and C, you have 15. The next one is B union C. The combination of all the elements in set B and C, avoiding repetition, you have this result. We are to show that this expression is equal to this expression. Bracket open, A intersection B, bracket close, union, bracket open, the intersection of A and C, equal to A intersection, the union of B and C in bracket. You have to start with the first side, and that side you have to consider the first set, the intersection of A and B, that is 20, the intersection of A and C, 15. You get the union of these two sets and you have these results. The second part, we need the union of B and C. You have it in this form. You compare set A with the union of B and C under intersection. The common elements to set A and the union of B and C, you have this result. Both are equal. Thus, this expression is equal to this expression. Example 24. Given that the universal set is equal to this, the elements are from 1 to 10, set P equal to this, set K is equal to this, you are asked to show that the complement of P union K is equal to P complement intersection K complement. Solution. We need to get P complement and K complement. P complement is the set that has every element in the universal set but not present in set P. In other words, if you remove all the elements in set P from the universal set, the remaining elements will form P complement. You have it in this form. Same with K complement. You have this result. Next, we are to get P union K before the complement. The combination of the elements in set P and K form the union. You have this result. Next, you get the complement of P union K. That is the elements in the universal set but not in P union K. You have 5, 7, 8. That is the first part. The second part is P complement intersection K complement. That is comparing this set to this set under intersection, the common elements or elements. And you have 5, 7, 8. Hence, the complement of P union K is equal to P complement intersection K complement. Example 25. Let set A equal to this and set B equal to this. Find A union B, the intersection of A and B, the difference between A and B. From the given sets, all the elements in set A are also part of set B. The union is the combination of all the elements avoiding repetition. So 2, 3, 5, 7, 11, 13, they are also in set B. That is A itself, and this element 18. So A and 18, they are the union of the two sets. The intersection of A and B, the elements common to set A and B, that is 2, 3, 5, 7, 11, 13. They are also here. 18 is here, but 18 is not in set A. That means 18 is not common. So set A itself is the intersection of both sets. The difference between A and B is an empty set. Let's take the breakdown. This is set A. This is set B. Remember, set A is part of set B. Now, the difference between set A and set B is the set with elements in set A that are not found in set B. Let's try and compare the elements. 2 to 13, 2 to 13. In other words, there is no element in set A that is not in set B. So the difference is an empty set. I've already explained this. Now let's take it in this way. The difference between B and A, that is the element in set B that is not in set A. The element in set B that is not in set A. Compare the two sets. Which elements or elements you have in set B that is not in set A? That is 18. So the difference between B and A has one element 18, while the difference between A and B is an empty set. Example 26, given the universal set S equal to this, and A, B, and C are subsets defined as A equal to odd numbers, B even numbers, C prime numbers. List the elements of A intersection C, the union of A and C, the union of B and C, B complement intersection bracket open, B intersection C bracket close, A union bracket open, B complement intersection C complement bracket close. Show also that A complement is equal to A. Solution: you start by listing the elements in the universal set. By the given range, 2 and 15 are inclusive. So you list the elements between 2 and 15. Let's define subset A. That set has elements that are odd numbers. From this set, you have set A, numbers that when 2 divide them, there is always a remainder of 1. Subset B, even numbers. From this set, you have the subset B. Subset C, prime numbers, number with 2 factors, 1 and itself. You have this results. We are to list the intersection of A and C, the common elements to set A and C. You have these results: A union C, the combination of the elements in set A and C, avoiding repetition. You have these results: B union C, the combination of the elements in set B and C, avoiding repetition. You have this result. For us to list the elements in this set, we need to get B complement. B complement is the set that has every element in the universal set but not present in set B. You have this result. We have to get B intersection C, and you have 2. After that, you compare B complement to this set under intersection, and both sets have known common element, that is an empty set. For us to list the elements in this set, you need to get C complement, because we know B complement already. So C complement is a set that has every element in the universal set but not found in set C. You have this result. Let's get the intersection of B complement and C complement, the common elements to this set and this set. You have 9, 15. We are to compare set A, this set A, with this set under union, the combination of the elements in set A and this set. You have this result. We are to show that A complement is equal to A, is equal to A. First, you need to get A complement. A complement is the set of elements that are in the universal set but not in set A. You have this result. Once again, you are now comparing A complement with the universal set. So here you get the elements that are in the universal set but not in A complement. You have this result, and this result is equal to set A. So A complement is equal to set A itself. End of lesson 4. Thanks for following to the end. Don't forget, watch out for more from the voice of Peter Kors. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the one that can save you, and that is the Lord Jesus Christ, and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations, live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every gathering of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.